Well, howdy, howdy, friends and neighbors. This is Country Dr. E reporting in for Advanced Finance. No, I can't keep that up. I can't do that country accent for too long. I'm a city boy from Charleston, South Carolina, so I can't do that country accent. But I like listening to people talk country for a little bit. So we are moving on to case number 7. Kind of like Dr. E. Too hot to handle. Too hot to handle. All right. Participation questions. Number 1. After you read the case and think about it, what kind of decision is Patsy? Is that Patsy Cline? Is Patsy making? Y'all even know who Patsy Cline is? You need to look her up. Patsy Cline. Look her up. Yes, it is a capital budgeting decision, but I think it is bigger than that. So, Patsy is making a strategic decision. It involves the services that her salon offers. It involves marketing. It involves accounting. It involves use of space. It involves returns. It involves business risk and financial risk. And it involves the mission and the image of her business. So all of these things together make this decision about whether to add tanning services and which technology to use. These are all strategic decisions. All right. Question 2. There is a new capital budgeting concept introduced in this case. What is it? What are the major techniques used to resolve it? All right, the issue is that the useful life of each unit is different. This means you have to find a way to offset the difference in the useful life. You cannot directly compare the net present value and internal rate of return of each technology because they don't have the same useful life. 2 techniques are used to address this challenge. The equivalent annual annuity approach involves computing the net present value for each project and then dividing the net present value by the annuity factor that corresponds with the cost of capital for the useful life of each project. Don't fret, I'm getting ready to work a problem that will illustrate this. For example, say the net present value of project A is $8.43 million. The net present value for project B is $14.16 million. Project A has a 5-year useful life and project B has a 10-year useful life. The cost of capital is 10%. All right, so let's work that problem. 2 projects, 2 different net present values, same cost of capital, but project A has a 5-year useful life and project B has a 10-year useful life. So, using the equivalent annual annuity approach, first we have to find the annuity factor for project A and B. All right, so for project A, this is how you find the annuity factor. 1 is your payment, and 5 is your N, 5 years, and 10 is your IY. Compute present value. fit it in over here. And we get a negative 3.7908. 3.7908. For project B, 1 is your payment, 10 is your in, 10 is your IY, compute present value, and you get minus 6.145. Let me make that look more like a 5. There you go. Now, what we do is we divide so for project A, you take the net present value, 8.43 million, and you divide it by 3.7908. And you get an annual net present value of 2.22 million. For project B, you take the net present value of 14.16 million. Okay? So I told you project A had a net present value of 8.43 million and project B had a net present value of 14.16 million. And you divide that by 6.145. And you get 2.304 million. Based on this, project B creates more value per year than project A. So you would choose project B. So this is one way to handle a situation where you have two projects that have different useful lives. Okay? Now let's find the other method, which is called the replacement chain method. And it requires you to forecast out cash flows to a common useful life. In this example, the common useful life would be 10 years, 5 years to 10 years. So we wouldn't have to do anything to project B, but what we would have to do is compute a net present value for project A 2 times over. So what we would have to do is we'd have to put in cash flows. Let me see if I can squeeze it in here, but for project A, you would have to go, so the initial cash outflow for project A, I didn't give you that, but it's $20 million, I think. Okay? And then you would have to, so that would be CF0, and CO1, I can't remember the exact numbers in the example, were like, I think it was like 7.5 million, 7.5 million a year. Okay, and FO1 was equal to 5. Okay. Well, here's the thing. Now, so that's the first set of cash flows. The second set of cash flows is another 20 million, and that happens at the end of year 5. And then, so CO6. So that's CO6, but you also have to find, so actually CO6 would be minus 20 million plus 7.5 million, okay? 7.5 million is the operating cash flow. 20 million is the initial cost. So then you have to run it again. You got to replace the machine, 20 million. 7.5 million, okay, so that's CO6, and that happens, FO6 happens once, and then CO7 is 7.5 million, and that happens 4 times. Then you find the net present value. So basically what you're doing is you're running the net present value for 2 consecutive terms, but remember that you have to replace the equipment again at the end of 5 years, and then you have to replace the, so I guess this happens in year 5. So this would be 4, FO1 would be 4, and then CO5 at the end of 5 years would be 20 million minus 20 million plus 7.5 million, and then CO6, yeah, would be 7.5, and that would run 4 times. You've got to get the cash flows right. In other words, you have to find the present value of $20 million that flows out at time 0 and at the end of 5 years. And you have to have, and then you have to find 7.5 million that comes in 1 year, 2 years, 3 years, and 4 years. The present value of minus 20 million plus 7.5 million at the end in 5 years, and then 7.5 million that comes in year 6, 7, 8, and 6, 7, 8, and 9. I'm trying to get the years right, but you understand what I'm trying to say here. That's how you do the replacement change method. Okay? In our example, in the book that you're looking at, one unit has a useful life of 8 years, the other has a useful life of 5 years, and the closest common value is 8 years times 5 years, 40 years. So you'll have to replace the dome 5 times, so you'll have to run cash flows 5 times, and you'll have to replace the bed 8 times, which gets you to 40 years, and so at that point you're running both projects for the same amount of time. So you can see that the equivalent annual annuity approach is much shorter. All right. How should the advertising cost be handled? Advertising is a sunk cost. Unless Patsy decides to spend more to advertise the tanning service than she currently is, you should not add advertising as an operating cost for the project. So I think she's spending $500 a month on advertising currently. If she does not change that $500 a month, if she does not add $100 a month to increase or enlarge her ads to add tanning, then you don't include the cash flow because it's a sunk cost. All right. Now the other questions are intended to help you start on the path of projecting cash flows for this project. What revenue does the average stylist generate in a year? Well, it says that the salon generates $500,000 a year, and there are 10 stylists. So 500,000 divided by 10, 50,000 per stylist. Okay? Assuming a stylist gets to keep 70% of the revenue they generate, how much will they make in a year? So typically there's a split between the stylist and the owner of the salon. And I use 70%. So if a stylist generates $50,000 in revenue, they get to keep 50,000 times 7, $35,000 in a year. Now the other question is, okay, so does the owner get to keep the whole 30%, or what about products that have to be purchased to so that the stylist can do his or her job? All right. How many customers does a stylist see in an average day? Well, obviously, if there are, and there are different ways of getting to this answer. They see 40 customers a day, okay, and they have 10 stylists. So the short answer is 4 customers a day is what they see, which means they spend, now, how many hours a week does the salon operate? Okay, so let's try to get a little bit more precise. Well, when you add up the number of hours that's listed in the case, 43 hours per week. So they're 10 stylists, 43 hours, that's 430 man hours. How many customers do they see in a week? 40 a day times 5 days a week. They're open 5 days a week, 200. So 430 man hours divided by 200 customers, they're spending 2.15 hours per customer, okay, which is approximately 4 customers per day. So this would be a good question. What do you think about that? Or if you had to make one change in, if you were a financial manager and you wanted to make one change to make this operation more profitable, what would it be? And I would say that they either need to figure out how to shorten the amount of time they spend with each customer so that they can see more customers in a workday. 2.15 hours seems like a long time to spend with an average customer. I understand if you're doing coloring, it takes more time. But while one customer is waiting for the perm or the coloring to take effect, a stylist should be able to work on another customer. So as a financial analyst, if I'm studying this, I'm thinking we need to shorten the amount of time. We need to cut it from 2.15 hours per customer to 1.4 hours per customer so we can get more customers in. Or you have to price it differently so that the procedures that take more time, you have a margin. You have to determine what your cost per minute is, and you have to determine a margin that will cover the added cost. Otherwise, now I realize that you can't. Let's say the highest margin is cutting hair. Can you do away with coloring because it takes too long and the margins aren't good? Probably not. Probably not, because if you do away with coloring, a person probably wants to come there to have their hair styled and colored or permed, and so it's a package deal. But I think you got to either tweak your pricing per procedure, or you have to see how you can either be more efficient with your time per customer, or can you work on more than one customer per procedure. All right, question number 5. How much tanning revenue per day can each bed generate? So the Dome, when they operate 8.3 hours on average, 8.3 hours, because they got a short Saturday and a little bit longer Friday, and then Tuesday, Wednesday, and Thursday, 10 hours. So I think it's 10 hours for 3 days, then it's 8 hours for Friday, and then I think it's 5 hours on Saturday. Okay, so it's a total of 498 minutes. If you divide, so the Dome is 498 minutes divided by 15 minutes, which is, they could do 4 sessions per hour, so that's 60 minutes divided by 4, that's 15 minutes. So they can do, so if you take 498 minutes divided by 15 minutes, that's 33 tans in an hour, I'm sorry, in a day, times $3 a day, a session, $99 a day. The bed, 498 minutes divided by 20 minutes. They can do 3 tans per hour, which is 20 minutes, 60 minutes divided by 3, 20 minutes per tan. So 498 minutes divided by 20 minutes is 24 and change tans, but you can't do a part tan, a partial tan. So it's 24 tans times $3, $72 a day for the bed. All right, what is the Dome variable cost per tanning visit? So what are the variable costs? Every time you use the machine, there's a cost associated with it, and there are two variable costs associated. One is the electricity. So with the Dome, you get 4 visits per hour. So the electricity is 50 cents an hour, so you divide 50 cents by 4 visits per hour, and you get 12.5 cents per visit for electricity. The bulbs, you use part of the bulbs each time you do a session. The dome has 48 bulbs times $22 per bulb. That's $1,056 in total, divided by 1,300 hours, which is their useful life, which is 0.8123 per hour, 81 cents per hour, divided by 4 sessions per hour, which is 0.2031, 20.3 cents. So 50 cents divided by 4 is 12.5 cents per visit. 48 bulbs times $22 per bulb is $1,056 total, divided by 1,300 hours is 81 cents per hour, divided by 4 is 20.3 cents per session. Total variable cost, 12.5 cents per visit plus 20.3 cents per visit, 32.8 cents per visit is the variable cost. Remember, the price is $3. For the bed, electricity is 50 cents divided by 3 sessions per hour. So their electricity is 16.67 cents per visit. The bulbs, 28 bulbs times $22 is a total of $616. Divided by 1,300 hours is 47.4 cents per hour. Divided by 3 sessions per hour is 15.8 cents per session. Their total variable cost, 16.67 cents per session for electricity, 15.8 cents per session for bulbs. Total variable cost, 32.47 cents per session. Question 7, how do you handle the lotion? Show your calculations. Well, each bottle of lotion that you sell contributes $5 per sale, and each bottle lasts 10 sessions. So with the dome, you do 33 tans per day times 5 days per week. Now here's an assumption. I am assuming that they're going to operate 49 weeks per year. 2 weeks for vacations and holidays. So 52, and then, well, I'm sorry, 3 weeks for vacations and holidays. So that would leave 49 weeks times 5 days per week. So that's 245 days per year operating times 33 tans per week is 8,085 sessions per year. So again, 5 days a week times 49 weeks is 245 days times 33 tans per day, 8,085 sessions per year. Divide this by 10 sessions because each bottle does 10 sessions, and you get 809 sessions per year times $5 profit per bottle is $4,045 in profit from the lotion for the dome. Okay, for the bed, they do 24 tans per day